Okay, fourth graders, today we're doing Module 3, Lesson 34. And we've been working a lot with division, but today we're going to switch gears and talk about multiplication, okay? And what we're going to do is, we've talked about multiplication before, but today we're going to learn how to multiply two-digit numbers with two-digit numbers. We haven't done that yet, so this is new. And the strategy we're going to be using today is not the strategy you'll be using your whole life, but it's a step into the standard algorithm. And what we're going to be doing is using a place value chart. You guys are very familiar with using place value charts. So we're going to revisit our friend place value chart. If I have 40 times 22, could I use what I know about factors to break apart 40? 40 is the same as what times 10? Avani?
4.
4. So is 40 times 22 the same thing as 4 times 10 times 22? That's what we were saying earlier during the problem of the day, right? We could see that it's the same as 4 times 10 times 22. Now there's a property of multiplication that says I could associate with these people, but then I could also associate with these people and it's the same value. What property says I could do that? Everyone? Associative property tells me that originally I was thinking about 4 and 10 together because that makes 40. But could I also think about the 10 and the 22 in parentheses together? Does it change the value of the multiplication? No. So I could think of this as 10 times 22 and then times 4, couldn't I? Yeah, I could. Because that's what I'm doing here. I have 10 times 22 and then I have 4 copies of 10 times 22. Do you guys agree? Do you guys agree? Okay, now, how could we use a place value chart to show 10 times 22? Well, start by drawing a place value chart and labeling it with the hundreds, tens, and ones columns. I have 22, which means I have how many tens? 2. And then how many ones? 2. If I want to multiply 22 times 10, how do the digits shift when I multiply by 10? They shift to the left by 1 column, right? So that means that my 2 tens will become 2 hundreds, and then my 2 ones will become 2 tens. So what's 22 times 10 based on our place value chart? 220. But is that my final answer? No, because I have to multiply it by 4. I can make 4 copies of it. There's 1 copy, 2 copies, 3 copies, 4 copies. 1 copy, 2 copies, 3 copies, 4 copies. So after I multiply by 10 and multiply by 4, how many do I have altogether? How many hundreds do I have now? Everyone? 8. How many tens do I have altogether? 8. And how many ones do I have now? So what is 4 times 10 times 22? Everyone? 880. What we did here is we used the associative property to break apart the factors and then multiply by a factor of 10 first and then multiply by the other single digit. Do you guys see that? Let's use those same steps to try another problem. This time we're doing 50 times 31. We can use what we know about factors to break apart 50. We know that 50 is the same as what times what? We want a factor of 10. Anshul? Good, 5 times 10. So we can say that 50 times 31 is the same as 5 times 10 times 31. Yes? Then using some property of multiplication, we can say that this is the same thing as 5, and then we can think of the 10 times 31 as a group. What property is that called again? Everyone? Associative property. Good. Write it down. Write down that that's the associative property. Okay. Now, how does this help us? Well, now we have 31 times 10, don't we? Could we use a place value chart to help us do that? Let's do it. Let's set up a place value chart with hundreds place, with a tens place, and a ones place. If I have 31, how many tens discs do I need? Everyone? 3. And do I need any hundreds discs? No. Do I need any ones discs? How many do I need? Okay. Go ahead and draw 31. Now, if I'm going to multiply by 10, how does that affect the discs? They're going to all shift one place to the left. So go ahead and draw an arrow, and then with the arrow, also write times 10 and times 10. So my 3 tens discs end up in the hundreds column, and my 1 ones disc ends up into the tens column. So what is 10 times 31? What is 10 times 31? Look at our discs. What do we have? 300? 10. Good. Are we done? No, because we still have to make 5 copies of it. So there's 1 copy, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now let's see what we have. How many hundreds do we have? How many hundreds do we have? Sparsh? 15. So what can we do with 10 of these hundreds? What can we do with 10 of these hundreds? I gotta add something first. Varshini, what could we do? We could regroup them to become 1,000. So altogether we have 1,000. Now how many how many hundreds do we have? 5. How many tens do we have? Everyone?
5.
How many ones do we have? 0. Don't forget that this is before we did the multiplication by 10. So our answer is 1,550. Again, we use the associative property as well as a place value chart to help us multiply a 2-digit number by a 2-digit number. When we think of an area model, we can say that this is 40 and this is 43, right? But we can break apart 43 to become 40 plus 3. Do you guys agree? Yes? So then when we did the area model, we did 40 times 40 to find this part, or 40 times 40, right? And then we did, how do we find the area of this part right here? 40 times 3. 40 times 3. So this is the distributive property, okay? Because we're distributing the first factor of 40 to both parts of the second factor. Does that make sense? So let's go ahead and find the area. How do I find 40 times 40? I can do 4 tens times 4 tens, right? What's 4 times 4? 16. What's 10 times 10? So 16 hundreds, which is 1,600, right? Okay, and then for the next part, I have 40 times 3. 40 is the same as 4 tens, right? So what's 4 times 3? 12. What's 4 tens times 3? 12 tens, or 120. So then how do I find the total area? I have to add up 1,600 plus 120, which is 1,720. So we use the distributive property, by breaking up the second factor and distributing the first factor to both parts. Does that make sense? It really helps to draw an area model when we're thinking about the distributive property.